You heard that right. We're about to draw a parallel between two seemingly disparate worlds, the fast-paced consumer electronics industry and the traditionally slow-moving realm of military aviation. Imagine your smartphone, designed, built, and upgraded at lightning speed. New models appear annually, packed with enhanced features and capabilities. Now picture that same philosophy applied to fighter jets. It sounds radical, doesn't it? China's vision? Build jets faster, smarter, and more adaptably, constantly evolving to meet emerging threats. Just like the tech in your pocket. Think about the apps you update weekly, the new operating systems, the constant stream of improvements. This isn't just about speeding up assembly lines, it's far more profound than that. It's a total rethink of how advanced military hardware is made, from initial design to long-term maintenance and upgrades. In this future, a jet's power isn't just its engine or airframe, the raw physical capabilities, but the software running inside, the algorithms that dictate its performance and adaptability. Instead of waiting a decade for upgrades, a process that can be incredibly costly and time-consuming, imagine new features delivered by software patches, just like your phone. Instant improvements, readily available. This could flip the entire aerospace game, creating a more dynamic and responsive defense ecosystem. The core idea: modularity and iteration. Build systems that can be easily swapped and upgraded. Build a solid platform, then upgrade relentlessly. Keep the core strong, but constantly evolve the peripherals. Applying this to fighter jets is a massive challenge, given the complexity and safety-critical nature of these machines. But with AI and advanced manufacturing, including robotics and 3D printing, it's becoming reality. The tools are now available to make this vision a tangible possibility. We'll explore the minds behind this vision, the engineers and innovators pushing the boundaries of what's possible, the machines already showing these changes, and what it means to build a jet like a smartphone. What are the implications for cost, performance, and national security? Here, code is as crucial as wings and engines. The software defines the jet's capabilities, its sensors, its weapon systems. Forget what you thought you knew about jet manufacturing. This is a new blueprint being drawn up right now. A digital blueprint, constantly evolving and adapting. It's speed, innovation, and a relentless drive to build the future of air power. Buckle up. Let's see how they plan to solve this engineering puzzle and what the future holds for fighter jet design and manufacturing. Every revolution needs a visionary. For China's aerospace leap, that's Sun Cong. Sun Cong isn't just a chief designer. He's the force behind China's most advanced jets, like the J-15 and the evolving J-35. He's pushing to transform jet development from a slow, decades-long process into a rapid, iterative, high-tech cycle. His philosophy? Build jets with modular upgrades like apps for your phone. Sun Cong leverages China's tech and manufacturing might, asking, why can't we innovate in defense as fast as we do in consumer tech? Traditionally, jets are locked into one design for decades. Sun Cong wants continuous evolution, hardware modules and software updates rolling out all the time. He's not just building planes, he's building a new kind of aerospace industry. By championing open architecture and AI-driven design, he's setting China up to out-innovate its rivals. If anyone can pull off this disruptive vision, it's Sun Cong. How do you go from the traditionally slow process of jet building, often taking years, to rapid smartphone-like cycles of development and deployment? It's a question that has plagued the aerospace industry for decades. The answer lies in artificial intelligence. AI is now intricately woven into every stage of aircraft design, manufacturing, and operation, from the initial digital blueprints and simulations to the high-stakes environment of combat missions. It's a complete transformation. In the design phase, AI runs millions of simulations overnight, far more than any human team could accomplish in the same time frame, meticulously finding optimal shapes, materials, and systems in a matter of months, a process that traditionally took years of painstaking work. On the factory floor, AI-powered robotics assemble jets with incredible precision, offering a level of accuracy and speed that human workers simply can't match, leading to fewer errors and faster production times. AI also manages complex supply chains, intelligently predicts part needs before they become critical shortages, and uses advanced imaging to spot even the most minute defects in real time, ensuring the highest quality standards. In the cockpit, AI transforms the pilot from a mere operator into a battlefield strategist, capable of managing and coordinating swarms of unmanned drones with ease. These AI-powered wingmen can scout ahead, jam enemy communications, and even autonomously engage targets with pinpoint accuracy, all seamlessly coordinated by the pilot's intelligent digital co-pilot, freeing them to focus on higher-level strategic decisions. The result of all this? Radically faster development cycles, smarter and more efficient manufacturing processes, and a completely new era of air combat capabilities. The pilot of the future becomes a quarterback, orchestrating the battle from above, commanding a diverse team of AI-driven assets that can react and adapt in real time. This is the ultimate software-driven jet, a paradigm shift where lines of code, not just raw hardware power, define the cutting edge of aerial warfare. China's strategic bet is clear that AI will shatter traditional aerospace bottlenecks, unlocking unprecedented levels of efficiency and innovation, and ultimately redefine the very nature of air power in the 21st century. The future of the skies is increasingly unmanned, heavily reliant on AI, and evolving at an unprecedented digital speed. To truly understand China's rapid technological advancement, we need to look beyond the surface. A great example is the J-15 Flying Shark. When it first appeared, critics were quick to label it a Russian clone, pointing to its similarities with the Sukhoi Su-33. But that assessment misses the bigger picture and the strategic intent behind it. China started with a Russian template, acquiring the basic design and understanding the core principles. Then they relentlessly iterated, swapping in homegrown tech and refining the design to meet their specific needs. In its early iterations, the J-15S used Russian engines, a necessary starting point. But China didn't stop there. They invested heavily and eventually developed its own WS-10 engine. This breakthrough broke their dependence on foreign suppliers and enabled rapid upgrades and improvements to the aircraft's performance. The avionics, radar systems, and weapons capabilities have all been systematically replaced with advanced Chinese systems, showcasing their growing technological prowess. These replacements often resulted in significant improvements over the original Russian components, demonstrating China's capacity for innovation. The J-15 became a crucial testbed, providing invaluable experience for mastering the complexities of carrier landings. It also served as a platform for developing and refining high-performance engines. It's the critical bridge from simply copying existing technology to true innovation, solid proof that China possesses the ability to rapidly evolve and improve upon complex technologies. The lessons learned from the J-15's evolution, from its initial design to its current capabilities, are now directly fueling the development of the next generation of Chinese fighter jets. Like the advanced J-35, the Flying Shark wasn't the ultimate end goal in itself. It was the absolutely essential first step on a much larger journey of technological advancement. China's overall strategy is clear. Start by establishing a solid foundation and a reliable base, and then relentlessly out-iterate the competition through continuous improvement and innovation. The J-15 serves as a powerful example of just how quickly a perceived copy can evolve and transform into a cutting-edge platform for true innovation and technological advancement. And the future? It's all about relentless pursuit of homegrown upgrades and continuous refinement of their own technology. If the J-15 was a stepping stone, the J-35 is China's leap into the future. This stealth fighter embodies Sun Cong's vision-rapid development, modular upgrades, and cutting-edge tech. The J-35 evolved from the FC-31 prototype, refined through years of private testing before entering service. This approach slashed development time. No more waiting decades for a new jet. The J-35 features advanced radar, 360-degree vision, and AI-assisted cockpit systems. Its open architecture design means software and hardware can be upgraded like a smartphone. New sensors or weapons? Just update the code. The J-35 is proof China can build, adapt, and deploy world-class jets at record speed. It's not just a new fighter. It's a new way of thinking about military power. China's aerospace industry is now competing at the highest level, focused on speed and adaptability. Traditionally, building a new jet took decades. Designs were frozen, upgrades were rare and costly. By the time a jet entered service, threats and tech had already changed. Major upgrades meant expensive, time-consuming overhauls. China's new model flips this. Start with a flexible, modular platform, then upgrade continuously. The first version gets into pilots' hands fast. The next version, with better modules, follows in just a few years. It's a cycle of constant improvement, not a one-and-done project. New tech? Plug it in as a module. New threat? push a software update. This approach turns air power into a nimble, evolving force. The focus shifts from hardware perfection to rapid adaptability. Instead of betting everything on one design, China makes a series of smarter, smaller bets. The result? A fleet that evolves as fast as the world changes. It's a shift from hardware-defined to software-defined power. The key to this revolution? Modularity. Think of building a computer. Swap out parts, upgrade as needed. Now apply that to fighter jets' engines, radars, and even fuselage sections as interchangeable modules. Breakthrough in radar tech? Just swap the module, not the whole jet. Factories specialize in different modules, building them in parallel for faster assembly. This makes production quicker and the supply chain more resilient. Modularity means you can customize jets for different missions by swapping modules, air-to-air combat, install a long-range radar, ground attack, add a sensor pod, the same airframe, endless configurations. This flexibility is impossible with traditional designs. It's about building a versatile platform, not a single-purpose tool. The result, jets that adapt as fast as the mission changes. If modular hardware is the body, software is the soul. The real game changer. Upgrading a jet's capabilities with a software patch. Modern radars, sensors, and weapons are all defined by code. Update the software, and the jet gets new features, no wrenches required. This is software-defined aviation, a stable airframe, constantly evolving code. Open architecture lets engineers add new apps to the jet, just like your phone. New weapon? Install the software. New AI? Update the brain. The jet that takes off in the morning could land with new abilities by afternoon. In this era, the best coders matter as much as the best engineers. The rules of air power are being rewritten by software. So what does this all add up to? A seismic shift in military aerospace. China's build jets like smartphones vision is a strategic doctrine, not just a tech experiment. If successful, it means faster responses to threats and tech advances than legacy powers can match. The risks are huge. Fighter jets are still the most complex machines on Earth, but the rewards could be game-changing. For tech enthusiasts, it's the ultimate engineering challenge. Blending AI, modularity, and rapid iteration with extreme reliability. The future of air combat will be won by the smartest, most adaptable, and most quickly upgraded fleets. China is betting big on this new paradigm, and it's already changing the global conversation. The race for the sky